If you're just starting to think about incorporating AI, the most important thing you can do is get a sense of what you're starting with. Too frequently, executives start major AI initiatives without hiring any experienced AI practitioners, or they hire very expensive people and then have them twiddle their thumbs for months while the rest of the organization scrambles to collect data, or they ask machine learning engineers to analyze massive amounts of data on tiny laptops, or they make any number of major mistakes that boil down to mismatched resources. Save yourself from making those mistakes. Make sure you have what you need before you really start. If you don't know how to do the resource survey, learn from people who do. Outside experts might seem expensive, but they're a lot cheaper and much less embarrassing than AI projects that are doomed to fail. There are 5 types of resources needed to apply AI in any organization: people, data, hardware, software, and algorithms, in roughly that order of priority. Of the 5 types of resources, people are the most important. If you've decided to seriously invest in AI, it's worth building some in-house expertise. That involves both teaching your existing staff how to be AI literate, as well as potentially hiring senior practitioners who can start building the team and marshaling the rest of the resources they need. With the right people, they can figure out the rest of the resources. Without the right people, all the resources in the world won't help you do anything useful. Helping your existing employees become AI literate involves enabling them to take courses like this, or to go to AI meetups, or to invite AI practitioners to speak at the organization, or to send them back to school to take some continuing education classes, or any number of things. It's definitely helpful to have a structured training program mapped out, but you can also just ask who is interested in learning more about AI, introduce them to each other, give them some resources, and mostly get out of their way, because chances are they'll find some of the best learning opportunities on their own. Hiring senior practitioners is unfortunately one of the most challenging things you will have to do. There are very few people who have experience leading AI projects and teams, and those few people are in very, very high demand. Most of the people I've worked with have only really had success tapping their personal network and working with high-end, specialized recruiters. For example, to build out their self-driving car research team, Uber hired 1/3 of the professors and researchers from Carnegie Mellon's National Robotics Engineering Center, a total of 50 people, up to and including the center's director. That type of expertise does not come cheap. And after all this, you might decide that building this in-house team is too costly, and that you would rather partner with startups or universities or consulting companies. That can work really well if you choose your partners carefully. Again, there aren't many people or organizations that have experience working on serious AI projects, and those that do often want to hoard their knowledge as a competitive advantage. Make sure that the people you're working with have successfully delivered something similar before, and try to learn as much as you can from them. One very important thing to keep in mind here is that, as we talked about earlier, over the next 5 to 10 years, AI will empower people, not replace them. Almost 70% of insurance executives believe that automation will result in a net gain of jobs for their organization as they reskill existing employees or hire new ones. Even if you decide to work with outside talent, you still need in-house employees who understand how to work with this new generation of AI-powered tools. Data is the next most important resource. Most AI practitioners spend more than 60% of their time gathering and preparing data. you need to make sure that your organization actually keeps track of the data it has, that the data is digitized and of reasonably high quality, that you know where the data came from, that internal company politics won't prevent your AI team from getting access to the data, and that there's enough of the right kind of data for them to do something useful. Take none of these things for granted. Data can also be another form of a competitive advantage. Data is often the secret sauce of modern AI applications, and if only you have access to that data, none of your competitors can use it to build their own apps. One of the best things you can do now is start making sure you're gathering as much data as you can and that you have a plan to eventually use it. I want to emphasize the importance of knowing how you're going to eventually use that data. I've personally had several experiences where companies decide to collect data on their own for a few years, and only then have hired me or others like me to come in and start doing something useful with it. But we quickly find out that they've been missing a crucial variable the entire time, and we can't use any of the data that they've collected over the past couple of years. As part of your data gathering process, make sure AI practitioners are involved so they can provide some basic sanity checks that yes, it looks like you'll have everything you need when you start incorporating AI later. Data can come from your customers, your own internal processes, public data sets like government records, or third-party data vendors. Whatever data you collect, make sure that you are complying with the relevant regulatory frameworks around privacy, like GDPR. As we've said several times before, much of the recent success in applied artificial intelligence is due to the power of modern computers. Make sure that your team can actually run things on those beefy computers. Often, that means things like clearing cloud computing services like AWS or Google Cloud or Microsoft Azure with your regulatory and cybersecurity departments. Or if you're limited to in-house machines, making sure that your team has laptops that can do more than crash when loading Excel. You'd be surprised at how many engineers default to suffering through slow processing times rather than ask for a slightly better computer. When in doubt, ask the technical team if more computing power would speed things up. Fortunately, for software, there are many existing packages to help with AI. Everything from commercial platforms like H2O to free and open source software like the Python library scikit-learn. Different software packages specialize in different things, and all you really need to do here is give your AI managers and engineers a voice when deciding what software tools they can use. If something is particularly well suited or ill suited, they'll let you know. Frequently, you want to let people use tools that they're already familiar with. Don't hire Mac developers and expect them to hit the ground running if you hand them Windows laptops. However, you do want to make sure there's some common ground. For your team to function well together, people need to be able to understand what other people are working on, and establishing a common list of core programming languages and packages that everyone uses is often a key step towards this. The fifth and final type of resource is algorithms. Algorithms are the least important resource because the vast majority of AI practitioners never really invent new algorithms. Most popular algorithms are already implemented in free and open source software, like the Python library scikit-learn that we mentioned earlier, and new algorithms are frequently released with the source code for people to play around with. In fact, many researchers spend years studying the mathematical intuitions behind the algorithms, only to graduate with a PhD and come to industry and find that they spend most of their time understanding the business needs, gathering and cleaning data, and learning how to code alongside others in a production environment. and many other tasks almost completely unrelated to understanding or inventing algorithms. And once you know what resources you have, it's time to get started on actually using those resources to build AI systems. In the next lecture, we'll talk about descriptive, predictive, and prescriptive analysis, a framework you can use to better understand what most applied AI projects are actually trying to deliver.